Hi all, very good morning. Uh,
Good morning, Ashish.
Good morning. I'm joining. Okay. So we met again. Good guys. Okay. Yeah. So let me share my screen. Okay. So today we have our this bit of data structure related concepts that we're going to see. So, guys, any query or anything that you want to discuss before we start? People are joining. Let's give 1 or 2 more minutes.
So like I have few questions related to file handling.
File handling. Okay.
Yes, if
Okay,
the path is not the current directory, like last time you showed in Colab that the path is content, right? The main directory is content.
Huh.
In case if it is not content, something like some files we need to, read or write from the system. Like how do we do that?
So instead of content, you have to just write the path like C drive, then slash, then the folder name where the file exists, then slash the file name. Only you need to
Okay,
replace that.
the path name with the file name.
Yeah, so file name and where the file is situated in your system, like in C drive or D drive or any particular folder.
Okay. Okay, I will try and get that to you.
Huh.
Thank you.
So yeah, so if you see in the D drive, suppose there is a folder called a new folder. So D slash then new folder, then slash the CSV file name. That's all.
Okay. Thank you.
Okay. Great. Okay, so in the today's topic, we are going to cover what is algorithmic thinking, what is the complexity of a coding that you are writing, and what we mean by efficiency and time complexity. We'll see few of the algorithms that we are going to use through code, that is binary search, Euclid's algorithm like this, and data structure, stack, heap, and binary trees. We'll see. So people, those who are hearing this term for the first time, please don't worry. We'll try to make it generalize as possible as it is. So shall we start? Okay, 15 people. Okay. So what is the algorithmic thinking now why we are covering these topics? Because when we are writing codes for any kind of business project or solution, so we need to write a robust code in the sense like if 5 people are writing for the same code, then you need to see by writing code whose time like taking very less time, like who is taking very less time in terms of writing codes and all. So that is also one factor where it will decide whether how skillfully you are writing any kinds of code. Okay, so to understand that, let's first understand what is algorithmic thinking. Okay, so algorithmic thinking has close ties to computer science and mathematics. So when I say that computer science and mathematics, it is a combination of both, right? So simultaneously you have to think like a computational point of view as well as in a computer science or coding point of view. And these algorithms are nothing but it is the step by step instruction that you are going to give to the machine, Okay, that means like you are telling machine first do this, then first do this, then first do this. So this is the step-by-step approach, or how to run the sequence of codes. Okay, so when you have a complex problem, you break those into small steps, and make the computer understand how these steps are going to be performed.
But
Okay.
Ashish, like the program is also do the same thing, right? It shows the system to how to work and how to execute the programs and all those, right? So what's the difference between this algorithm and then the program that
Correct.
both do the same work, right?
Correct. So so when we say program, behind the program, we are actually telling the machine to perform an algorithm. That means, suppose we write a for loop, that is a piece of code. So we are telling the machine to run a for loop step by step. That means go for one element or the first element, or then go for the second element, then go for the third element, like that. So this is nothing like not different from that what we are writing the codes, right? So see, knowing what algorithm is very different from thinking algorithmically. It's the difference between memorizing a formula and constructing your own. Like, are you getting what is the difference here? So instead of memorizing a code, if you understand it, and if you understand the flow or the steps that it is going to be performed, then you can write the code in different ways, not in one way. If I'll give you one coding practice to like to you all, then the way of writing the code will be different, and it will vary from person to person. So this variance is coming because of because of our thinking inside the mind. Like we are constructing the steps. Okay, first we need to iterate over the loop, then we'll check the condition. So this thinking, which is coming to our mind automatically based on our understanding. It is totally different, like someone has written the code and you have started memorizing it, because that code you can write in different ways on your own as well. So when you do that, that is called algorithmically thinking, or algorithmic thinking. That you are thinking something and you are constructing something on your in your mind, that what should be the first step and what should be the first line of code that you are going to write. Okay, now when we think algorithmically, and we write our code, there are certain things that comes to picture, and it is very important while you developing a piece of code or piece of application. So first of all, so algorithmic efficiency and complexity. So to understand that, let's deep dive into it. Like algorithmic efficiency refers to how quickly that I told, right? Like five people wrote the same piece of code, whose code is giving me the results quickly. Like quickly we're getting the output or the required results from five persons. That will decide how efficient and robust code you are writing. And those parameters to consider someone's code as robust or skilled or clean code, that depends on few of the parameters, which is called a time complexity and space complexity. So two things you are going to be asked when you are writing a code, or you will get also this kind of question while writing the code. Got anything, something? So someone like Ritika is saying, sir, can you share the scheduled syllabus? Oh, this one you are talking about, right? This modules. Yeah, please have it, everyone, so that you will also get to up to date. And in case of anything that you need, you can tell from here. Right. Now, let's try to understand with examples, like what is this time complexity and space complexity. Okay. So what is time complexity? If you read the definition, time complexity is the number of operations an algorithm performs to complete its task, considering that each operation takes the same amount of time. The algorithm that performs the task in the smallest number of operations is considered the most efficient one in terms of time complexity. Did you get what it is saying? So that means when we run a for loop, it is iterating over the list, right? Now the question is, what is the time taking it is to iterate over the whole list and give us the required output? Suppose from if list has contains 100 elements, then when you run a for loop and wrote your code and completed those for loop with these 100 elements, then what is the time taken to execute that code? That is called as time complexity. Now, when I say execute the code, what I mean, that means the operation that I'm performing. Suppose while iterating, I am checking a condition whether, suppose a list is given with 100 elements, and we have to find a particular element inside the list. Now, a simple way is to iterate over whole list, and at last you say where you found the element. Or you can use a continue and break statement, which if you recollect how we wrote, to stop the loop as soon as you get the required output. So if you used a break loop or continue loop, there as soon as you found the element from the 100 elements, you are stopping your code execution. Now someone didn't wrote that break element. I'm just giving one small example. Someone didn't wrote that break element and it found the element, but still it is iterating over those whole list. And after completing the whole list, it is telling you where the element exactly is. Now, in which case the time will be less when you use a break, right? Because if you found it in between and you immediately stop executing the code, then the time you took to find the element will be less than if you perform a whole iteration over the list. Now, is this making sense? Or any clarification or any, you can share your understanding as well. It's not like, like you can also think in your way and, try to explain the time complexity here. The number of operations an algorithm performs to complete its task. So when I say number of operation, that means the mathematical operation I'm doing, the conditional operation that I'm doing, that checking whether this is greater than this or not. So these things will be taken into consideration, because these all things are taking some time to execute and taking some time to check the condition or any kind of mathematical operation. Suppose you are doing X, if A greater than B, then multiply A with 2 or A with 10, for example. So that is also one mathematical operation we are doing, that we are multiplying that number with 10. So that time is going to be considered as your operation, and that time is going to be considered inside your time complexity. Okay, so writing a robust code, a skilled developer will know. Okay, because a good developer can understand the code, but a skilled developer will write a robust code which will be time efficient and useful for the people. So time complexity means the time taken for the operations. Okay, now what is space complexity? So can you try to understand what is the space complexity when you write a piece of code or a chunk of code?
Yeah, it's like how much the memory was using. Like if it is using a lot of memory, there is a possibility to the system gets slow down, or else the system may get crash. So it has to be so minimalistic at the time execution, and also it has to be very minimalistic at the space usage, right?
Great, right. Yeah, you are also saying something, Diksha, right?
Yes, sir. Memory management.
Correct. So to understand this properly, if you see, suppose you are assigning a variable X, okay, inside your code, and you are storing some list or any number. So if you recollect, we are in our initial sessions, we are using a function called ID, right? And that ID was telling us where the location exactly we are storing that variable. So now, whenever we are creating the variables and storing the value, so that thing is going to take some space inside our system. And that will decide like total space it is going to take in your system, the number of variables that you used, okay, the number of initialization that you did, right? Suppose we initialize, if you recollect, while learning about while loop, we initialize some value. So those things are actually taking some value, or taking some memories inside our system, and that depends, or that will tell us how much space it will going to take inside our system. So that is also because in real life industries, this computing resources are cost associated. That means, like, if you go for deep learning or something like that, like deep learning or calculation or machine learning algorithm, so that depends on the GPU's processing and CPU's processing. Now we all know GPUs are like expensive, right? So if you write a code which is going to use more computing resources from your GPU, then that is a cost to the company. So now company will try to find such persons. So those persons who will write the code will take less computing resources in the organization, or their system they have developed, that will take less space, also less time, so that this will be cost efficient. So that's why this concept is coming into picture here. And how to know that, okay, let's try to understand with examples. So to understand this time complexity and space complexity, what we are going to do, we will, so basically the space complexity, that is like a different thing here. We are not, because that depends on your operating system, what system you are using. So we are not going deep into the space complexity, but the time complexity will be a vital part, okay, which will tell you how quickest this search is, or the code is giving you the result, okay. And to understand that, we have few algorithms here, uh, like a linear search algorithm, binary search algorithm, Euclid's algorithm. Now these are the basic computer science concepts. So like those who are from computer science background, I think they would have learned this from the starting of their BTech or something like that. But yeah, but those who are starting out seeing these things new also, please don't worry. Let's try to understand, because I also started like this. I had no exposure a few years back, how these algorithms are. Like I heard these terms, but in terms of code, how we are going to write. So here, what we are going to do, we are going to write the code for linear search and try to understand how this works. So in this way, we'll have a proper understanding what is a linear search, what is a binary search, what is a Euclid's algorithm. Okay, now let's try to understand this algorithm. So what is linear search? So what do we mean by linear? Something is linearly linear. So when we say something is linear, can you think something why when we call it as a linear thing?
If it is organized, right?
Okay, okay.
Uh,
So
Mathematically, it represents a line.
so I just lost your voice.
Mathematically, it represents a line.
Yeah, mathematically. So that is a good point also. So if you understand mathematically, so when you have a mathematical equation, when we call a mathematical equation as linear, let me.
When we get those direct answers, like no more of searching it here and there.
Okay, now if you can see my screen, so I wrote a linear equation here. Now here you are going to get these terms mathematically. again, you are doing the same thing in your data science machine learnings also. So suppose this is your output and this is your, sorry, this is your output and this is the expression to get this output. What is the expression? Ax plus b. Now here Ax is the independent variable, and based on x, the y value is going to change. X is the independent variable, it will vary, and a and b are the some constants, any constants. Now here this is a linear equation because the order of x is 1 here. When you have some equations like this, x square bx plus c, now this kind of equation is not linear. Why? Because this is the order of 2 here. So that means here x and, sorry, here y and x are linearly dependent to each other. That means if x will change in the same pattern, y is going to change. If x is going to decrease, y is going to decrease here, right? So it depends, the relationship between y and x are linear. And here if you see the relationship between y and x are not linear. Here is the order of 2, here order of 1. Right? So this is a mathematical way to understand linearity of two variables. Same thing, if you take this mathematical expression, if you exclude this mathematical expressions and think in that way, that like linear relationship between two things. So linear search algorithm will compare each element of the array to the search digit. That means there is no power or something you need to consider here, just the input, just the output. Okay, we'll see why it is called linear. So order of 1, that means you are like considering each element of the element and performing the output. Okay, so it will compare each element of the array. When it finds the search digit of the array, it will return to. That means you have been given one array or list, you can say array or list, and you have been provided one number in that list. Your job is to find the index number of a particular number. Now, when I say linear, that means each element I will try to search one by one, and when I found that element, I'll return true. So linear search is a simple search algorithm that involves looking for a target value in a list or array by checking each element in the list or array one by one. One by one it will check and it will tell you where exactly the number is. And starting at the first element and moving to the last, it is called linear search because it has the time complexity of order n. Now what is this order or O? We'll see. This is the notation, or you can say this is the syntax, or this is the terminology that you are going to use when you are talking about time complexity. Okay, order of, so this is a big O notation. Big O notation of what? Of how this is related to the input variables. So as we are going from element to element, each element, first element, then second element, the third element, that's why the order is linear here. That means n means, so if you recollect the equation I wrote, what is the order of x there? 1, right? So here also order of, so this is similar to that order of x. So order of n means order is 1. So when the order is 1, this is linear. This, what does this mean? That means that the running time of the code is directly proportional to the size of the input. Suppose you have 10, then you are going to take 10 element in the array or list, you are going to take less time. If you have 100 elements, then you are going to take more time. So depend on the size of array you are going to define here. Okay, so let's do some coding and try to understand it. What I did, I'll explain this code to you. Before that, what I did to capture the time taken for any code, I found a way. There is other ways as well. You can find it, but I found this is the most efficient way to see how much time a piece of code is taking. Okay, so for that, what I did, I used a library in Python called timeit. Okay, now this timeit library will help you to calculate the total time taken to execute a piece of function or piece of code. Okay, now let's try to understand what we are doing here. So what we did, we are defining one function. Now, what is this linear search algorithm is, we are going to implement this through a code. And for that, what we are going to do, you are using a function called linear search. So I am going to give my function name as linear search. Now, if you recollect how we write functions, df, then function name, then the parameters or arguments need to be used inside that function. So here, what is the parameters? One array and the target number. That means suppose you have given 100 elements in an array, 1 to 100. I'll tell you to find the time taken to get 50 from that array. So the target is here 50. For example, I'm saying. So I am going to give two inputs here in my function. One is the array, one is the number that I want to find inside that array. I hope this is making sense. Now let's see. I wrote a for
Single
loop.
element.
Yeah, single element. Like we have given a list of numbers or array of numbers. There we have to find a single element.
Can be a character or string also.
Correct. Anything. But here we'll see that with an example with number. Okay. So what is the code I have written inside this function? For ij in enumerate array. Can you recollect the enumerate function now? Which we learned in
index
our
value. It will give the index value, right?
Yes, index value
Both
and
an
the
index and value.
correct. So now this you can achieve by writing this also. I'm just writing this line. Okay, the substitute of this line for I in range length of array, and you are going to iterate over the array with the index or the I. So what does this mean? What I'm doing here? Here I am using enumerate function, but here what I did, I am trying to get the index number directly by using range function. Range. So if suppose my array contains 10 elements, then this piece of code will return me what? 10.
Yeah.
And when I say range 10, what does that mean? That means I am generating. So when I say range 10, what I am doing here, suppose I make a list of this range 10. What I'm going to get here?
0 to 9.
You missed
Correct.
R there.
Oh, sorry. Range 10. It's like not, oh, it is connecting.
Yeah.
So that means I am generating number from 0 to 9. You are correct, right? And that means this I is going to vary from 0 to 9. And I am iterating this index number through, like, by calling the array. Array first element is 0, array second element is 1. So same thing we can do, but if you see here, you have to do like this, but using enumerate, we need not to, pass, so how many functions we are using here? Range function and length function, right? But here using enumerate, we are doing both the things simultaneously. We are generating the index number, also the array value. So here the array value will be considered through array, then the index position. I hope this is clear. Okay? Both the things are same. Now
Okay, so
yeah.
with the for I comma j enumerate array, we were getting the value, and at the the index number, at the same time the array value. Both we were
Correct.
getting it through the enumerate, right?
Correct.
So is like the enumerate is used for that only.
Correct. So
Okay.
this is the efficient way to get the index number and the value at the same time using this inbuilt function. Now when we iterate, and what is our aim here? We have been provided one array and we have been provided one target. We need to check what is the index number for that target inside that array. So how to find that? So what is the value here? J, right? I is means index, J means value. So if value is equal to our target, so suppose we have given 1 to 100 in an array and our target is 50. So here the target is 50. So when it will iterate over the array and when it will find the value equal to target, that is 50, it will return the index number. Are you getting what we're doing here? When J, that means the value equal to target, we are returning the corresponding index number. So this,
Sorry to interrupt you.
yeah.
What is array? We have defined it in simple.
Okay, great. So this is a really basic concept, okay, between array and a list. So in a layman term, you can think both as the same thing, but bit of difference is in array, you are going to store similar items. Like if you are going to store integers, then only integers you have to store. If you are going to store names, then only names you are going to store. In an array, I'm talking. Okay, but in list, you can store multiple data types. Like if integer, then the name, then some other Boolean value. So list can contain different types of elements, different data types of elements. But an array means you are going to keep similar data types of elements. Could I explain? Is it making sense? Yeah. So this is the so basically, if you consider here list also, this is the same. But if you see here in this list, I only put numbers. Okay, but here also I can put some names like a. So if you see here, this is integer, this is a string. Now in an array, you won't be able to do it. That's why I used a list here and give that name to array. You can also create array in Python using NumPy library. So when you say NumPy library, there is a method called array, and if you pass this list, it will become array now. Let's not do that. Just try to understand what is the difference between
So
array.
list will be written in a set bracket, right? So if we were like defining an array, like how we have to write it, like do we have to import or what?
So if you see,
Okay, so only after importing the NumPy library only we can able to use array. Until and unless we are not doing it, we can't able to do it.
Yes. So this is a one way. So other ways also you can define an array, but the D type of this. So suppose if I'll copy like this, so I told this is my array. Now what is the data type? How to know that?
Print type.
Yeah, print also. If you don't print also, this is fine. So this is a list.
Yeah.
Okay. Now if you use NumPy library, and what you did actually, you did array equal to NumPy library array, and you print type of array. NumPy is not defined. Okay, that means I didn't run the library.
Yeah.
Here I ran the library, then here I ran it. Now can you see here the type? It became the ND array. ND means
NumPy ND
the
array.
NumPy ND array. So if you want to make something to array, you can achieve like this.
Okay, so until and unless without like using that NumPy library, we can't able to use the array in a program anywhere.
Correct.
So like why so like if list and tuple dictionaries we are using it like without using any libraries and all, why this array is like we
So
were using?
array in Python, actually this is a good question, and default value inside Python array d type in Python, if we'll type this, let's go what is like I used array using NumPy. If you see here,
Mhm.
when you type array d type in Python,
Yeah.
NumPy it is coming. So
Mhm.
maybe in Python it is not there. But
Okay, what is the D type means?
data type.
Okay,
So
data type. Okay.
data type integer, data type array, data type list. So if you want to convert something into array, then I think you have to use NumPy.
Okay, maybe
And,
like they are using
yeah.
the list because the array is little bit lack of efficient having a data, right? Because in list we can able to save integer and strings, but in the array we
Correct.
can able to save only one kind of data type. Maybe that could be a reason. I'm not sure.
Yes, correct. So array versus list, if you do a quick Google search with the image, if you do a quick Google search, you can find lots of things here. I'm not sure what is linked list. Why it is coming as linked list? List is used to collect items that usually consist of elements of multiple data types. An array is an vital component that collects several items of the same data type. Okay. So this is a basic difference, not much. Like here we are not going to use array. Here we are going to use list. Okay, but when I say array, that means you should understand I am going to consider the similar D types elements. Okay. Now, so let's try to understand. So this piece of function, now this is I wrote a code to perform the linear search algorithm. Okay, this is the smallest and simplest code that I can write for linear search algorithm, where it will iterate over each element of that array or list and find the target or return us the index value. Now let's try to calculate the time complexity here, because that's what we are learning, right? So times complexity of different algorithms. Now what I did, as I said,
And
I
Ashish,
used
sorry to cut you off. Like, what is the return minus one there? Like return I, okay, it is returning the
oh okay
index value.
Okay, got it. Sorry, I forgot that. So once you find the target, then you return the index number. This part is clear. This till this part, right? Now, once you didn't find that number, what you are going to return? What this function is going to return? So in case there is no such element, so suppose you have list of 1 to 100, and you are trying to find 101. So in that case, no index number will be returned, right? So in that case, it will return -1. Like I am writing here, if you don't finding that particular element in the list or array, you return -1. You got now?
Yeah.
Okay.
So I can like for your reference, you're writing -1 based on this kind of situation. So I can write like -2 or 0 in
Correct.
sometimes. If it is
Correct.
returning 0 also, that is fine.
Yeah, correct. So, but we'll see what is the use of this -1 here. We're
Okay.
going to see. And if you type return 0 or -2, then again you need to use that accordingly. We'll see that.
Sure.
And if you see, this is my function. Now let's try to create one array or list. Okay, so here please consider this as a list. Okay, but I have given the name as array. But if you see, this is a list, but list containing similar data types, that is integer. Okay, now what is the numbers 1 to 10, right? And what is our target? So we want to find the index number of the element 10. That means the last element. Now, if you see, this is a piece of code that you need to understand here, how we are calculating the time it. So using time it library, there is a method again called time it inside it. Okay, time it module. So we are calling time it module. From time it module, again, there is a method called time it. Okay, or function called time it. Now, what this time it function will take as input? These two parameters. A function with lambda expression and the number of times you are going to execute that function. Now, if I do this, it will give me a time taken for this piece of function that I'm passing as an argument. Now here in time it function, I am passing lambda function. here, can you tell me guys, like we went through the lambda function. What is the input here for lambda function? Can you try to think?
Actually, sir, when we learn about the lambda function, yeah, that time we are not use the functions in the same line. We are giving the using lambda function. We are do the operations. Here we are using that functions as a input. That before learn your search, that function we are used here. But that time you told me that using of lambda function, we can use the same function what we in the function what we do the operation. We are without doing that function, we will do the operation over the lambda in a single line, like the way you have told.
Correct, correct. Now this can you correlate what you just said, right? Lambda x and y and returning x plus y. Here, can you see I have not given any input here? Okay, just the column and the output. So this is just the output. That means I am using the lambda function without any argument. Without any argument, I am using the lambda function. So here, the reason why I am not using any argument, because I just want to call this function. That's all. I just want to call this function and I just want to execute this function. That's all. This is not related to any input parameter for lambda function. So using lambda function, so that means here, what is my input parameter? Empty, null, right? No input parameter. Just using lambda function, I am calling the linear search function.
So if it is like, if you are not giving any what do we call that, like any operations or any kind of stuff, then why we were using lambda over there? Like if without lambda also we can call that, right? Like time it, and then excluding the lambda also we can pass the arguments into that time.
This is
right?
how this time function to be written. This is how. So if you want, so time function used when you try to calculate the time of a execution of a function. So time function will take lambda function as a help and execute that function. You can't directly call the function here.
Okay, so time it will be written with a lambda.
Correct. Now, without a argument, how to write a function? So suppose print hi. So here my input parameter is x and y. Okay, are you seeing any use of x, y, y here? No, right? So if I'll remove this x and y, now this function doesn't take any argument, but it will run for me. So whenever I call this function, it will do what?
Print here, right?
Print hi. So same thing. So we are calling lambda function, which is doing some internal work. Here, what is the internal work? It is running this function. Okay, same thing is happening here.
Okay, so to use the time it function only, we were using the lambda. So that it will be executed flawlessly.
Yeah, it will be executed for us. And the second parameter is the number of times you want to execute the function. Okay. Now, why we are considering number of times? Suppose I ran this code right now, this piece of code. What is the time it will take in? Will be different, bit of different from what the time it took from the previous running execution. Okay, the slight difference will be there, fraction of seconds, because and why this fraction of seconds of difference is there? Because of the computing resources is being used in the Google Cloud server. The services running in your systems, the things or any task got scheduled, so that also delay, or so that's why I told like space complexity will be a bit different here. Based on your system, it will define. So now, if at every run it is going to be different, then how to calculate? If you want to calculate this for 3 times, so what it will do? It will run this linear search function. I'll remove this part. It will run this linear search function 3 times and take the average time it took automatically. So that's why time it function will be helpful to calculate the time. So when I say number equal to 3, that means this function is going to be executed thrice, and what is the time taken on an average, it will tell you in this form. time variable. So now this line is clear, right?
Ashish,
Yeah.
Okay, so like I'm just getting confused over here. So like we were using lambda, and then with the number equal 3, we were calling the function thrice. Like with the same line, we are using like it works as a for loop, and then it'll execute the function as a 3 times, or what? Like I'm getting
No,
lost over here.
so when I execute the function 3 times, what I'm doing 1, then 2, then 3, right? And I'm recording the time. So
Okay.
what I did manually, this time it module is doing it for me.
Okay, so we were not giving any kind of input to it, or what?
Yes, that we'll see. So here, if you see, we are giving the input here for this linear search with the array we defined and the target we want to find.
Yeah,
Here
10. Okay.
in this function, we are already giving the input.
Yeah.
And this function will run thrice. And what is the time taken on an average, it will return to you.
So it will calculate the time of the function that we have returned.
Correct. By passing the input, these things. So here, this is just the definition of the function. Here we are calling the function with the input parameter. Like array and target, we need to pass as argument, right? To this function.
Yeah.
So we were doing that here. We're calling the function with the input arguments, and we're calculating the time it is going to take.
Okay.
yeah, Ashish
Now-
wants. So
Yeah.
number is not a built-in function, right? It's a variable. So how is this working when you put number is equal to 3 and it's running the program?
So this is actually this piece of code. All the credit goes to this timeit library. So
Okay.
what is happening inside? This is inside timeit library. So some expert developers to help us, they wrote this timeit library for us, which is doing all this work we are explaining in the background. That we need not to worry.
Sure, thank you.
Okay.
Why did you in time equal to time it dot time it? Why did you write it twice? Like time it dot time
Okay, that is a very good question. So this is how, so if you recollect our class and object thing, so there is a class called timeit, and again inside the class there is a method called timeit. So first we are calling the class, then the respective method. So this name actually given by the developer who developed timeit module.
Okay, the second one we have created it. Like, we will give it the second class.
No. See, everything is written inside timeit. Now consider this timeit as a class. Okay. So if you recollect, we wrote the whole class. Then we created object and we started calling the method dog. Then the method is bark, eat, right? Remember? So dog1 dot bark, right? Same thing we are doing here. After creating the object, or like from this class, there is another, the developer gave a method also named as same as the class. So this is the name given by the developer who developed this timeit module.
Okay. Ashish, if you don't use lambda there, what will happen? Like, what is the use of the lambda?
Okay, that is a good. Okay, let's not play here. Let's play here above. Right. This. What is the library I need to import? That is a good question. Actually, I have not experimented like this, but yeah, we can try together. I'll remove now. Okay. Now let's see. Oh, sorry. You have to define the array and the target as well, because you are passing this array as an input, right? And you are calling the function. Now let's do it. Now, if you see here, if you want lambda function, only that function and started calling it, it will raise you some value error. And this value error is neither a string nor a callable. This is the by definition. So whoever wrote the timeit library, some piece of code was written in the background. So they have wrote this timeit function to work like this, that we need to follow.
Okay,
If
so
you
that
don't-
lambda function is nothing to do with the like the time it function. It is because of it's also like an syntax that we have. It is also so-called syntax for using the time it function, right?
Correct, correct. So
Okay.
here, not only we are learning the syntax, we are also learning others' way of writing syntax. Okay, so they built a module.
Mhm.
They wrote some code in the background, and they said like, boss, I wrote this class or method. If you want to use this method, you have to follow these rules. You have to call a lambda function, then you
Mhm.
have to pass the function, then you run it, or else my code won't run.
Okay,
Okay?
that number thing was we were expecting the code to do.
The number thing is how many times you want the time it module to run this exact function. How many times?
Okay.
So by passing this, you are telling the time it library to run this function 3 times
Okay.
and tell me the average time it took. If I make it 10, that means you are telling this time it function to run this particular function with this input 10
Or
times
10 times, yeah.
and tell me the average value.
Okay.
Okay.
So
Okay.
number is also a reserved variable. We cannot change it to any other variable.
No. Correct. You are correct. So this style of writing should be same. The variable or the parameter you need to pass inside this time it method should be asked. And if you want to learn about more, you can go to the official documentation. Time it function Python, if you type, then the official documentation will come, and if you go to this official documentation, more information about this time it function will be there, because we are just seeing only small part. Now this time it function can be used in various ways. That also, even I am also not sure about all the usage, right? But here, if you come here, you have a proper explanation through the documentation how the time it function can use, okay, or what are the parameters. So here number is not only one parameter. Here globals, STMT, setup. So what these parameters are, you have to go through this document to understand.
Okay. So the number is also predefined in this.
Predefined. So every module and class, it will be predefined here, and you will get a proper understanding by going through the documentation.
Okay.
Okay. Now, once this is clear, so this will tell us the number of time or the time will taken. So let's do it for only once. Okay, only we'll run once and we'll see what is the time it is going to take. Now once we find that, what is our aim here? We have to find the target index number of the element, right? So again I am going to call this function again. Why I'm doing this? Because I want to see the output. Here it is not the output. Here it is only storing the time, right? But to see the output, I have written this code. That is, again I call this function, and whatever this function is going to return, either return I or return -1, I am going to store inside a variable called index. Okay. And if index greater than equal to 0, so that means when it is not returning -1, when that means when it is returning some value, if index greater than equal to 0. Now if you recollect, when you said I can make it -2 or 0, right? So now this definition will change here. If you are making greater than equal to 0, that means you are not including 0. And if you return 0 here, by this condition, it will satisfy. So that's why I took -1 here, because this is the condition I'm going to use here. So if the return value of this function, which is going to store inside what? This index variable, if the return value is greater than 0, that means not -1 or more than -1, print the target was found at index this. Now, if you run this code, what is the output we are getting here? If you see here, the target 10 was found at index 9. That means the last element. Okay. And here at last, I wrote and in the else statement, if I don't find anything, suppose I'll give it 11 here, what will happen? The target
Minus
11 was, yeah, so it will return -1. So, but the code returns -1. But how we are handling to the users? To the users, we are telling that the target was not found. So whenever you are written -1, you are telling the users that the target is not found. So that's why if you see 11 here, I am getting what? The target 11 was not found.
Okay, so that's the reason you have used -1 there. If you use
Minus.
0 also, it'll
So-
the program will be collapsed.
Correct, correct. So if you used 0, then here you have to write what? You have to
Greater
remove
than,
this.
yeah.
Okay, so as I used -1, that's why I'm giving the small piece of a change. So based on your return type. Now at the last sentence, I am printing the total time taken for this code to be executed. And how, where I am getting that information? From this, right? Here we are storing the time, right? The time taken to execute the function. So here we printed out the statement where in which position we found the target. And using this variable, I wrote this print statement, total time taken is this variable. And when I say time colon dot 6f, what does this mean? I think you have already seen these things, right? I saw some, you are using Kolkata problems, right? So what does this mean?
So 6 digits floor.
Correct.
0.00.
So after the decimal point, it will be 6 digits, right? So I want my time consumed or time taken in this form. Now, what is the time it is showing us? 0.5, total 5, 0 and 4. Now without fraction, because yeah, makes sense, right? Only a small list with 10 numbers. Now this time will change if we increase this list or the array of, if we'll go from 1 to 1000, then this will take more time. And can we see that quickly? Can you tell me how to create immediately one list of 1000 elements from 1 to 1000 and use here?
Using the range function.
Right. So let's quickly see. So just to show you what is happening, I am making list, then range, then suppose 1000, right? And I will comment this out. So what does this mean? This means as same as the above line, but here the element is from 1 to 1000. Are you getting what I did here? What this function will return me?
Yeah.
A list of numbers which is from 1 to 1000. Now let's run this. Can you see same time was taken? Why it is so? Or less time, like it is 0.
Yeah, less than 1 second, like 3 seconds
Now-
only it was taken.
It's also calculating the number 10
Correct.
at which position.
Correct. Whether you try to search from 1 to 10 or from 1 to 1000, you are searching for target equal to 10. Let's now change it to 9999. Why I'm taking 900? So this is the last element. Are you getting why this is the last element?
Yes,
The index will be like from 0
-1.
to 999. Yeah.
Correct. So
Time
now
may
let's
be
see this
taken.
one. Let's see this one.
more.
Now can you see what happened? It
Time
took
taken.
bit more time because this is the last element, and when it iterated over from 1 to 999, it took bit more second. Okay, so that's why. So this is just to show you that like why this took very less time, and if you increase the number of your lists, then the time is also going to increase.
Ashish, how did you write that time calculation function?
This one?
No, that last one. You are calculating the print of elapsed time.
Oh, this one. Okay. Yeah. So if you recollect our print statement of string formatting, right? This is the string formatting. I wrote F, right? Formatted string formatting, and elapsed timing is my what writing statement, and the blank space, if you recollect, blank space we are giving to capture the value here, and this much seconds. Now in the blank space you can just write this. Now if I
Okay,
do this,
what does that mean if you are writing in that blank statement you are entering time? What does that mean?
yes, now can you see the difference here, what I'm getting here? Here I am getting
Okay.
digits up to so many digits, right? To make
Yeah.
it, so I want to find after decimal 6. So not this much. This is 10 to the power 6.317999 something into 10 to the power -5, right? So this is a too big number to digest and too small number
Okay.
also. Okay.
Mm.
To see a proper value, we are using this format. So this is a format to be printing the floating value. Here you are telling the system, I don't need all the float values. Instead of that, only 6 digit, first 6 digit of that float value after decimal.
Okay. Got it.
Okay, so if you do this, then only this value will be populated to you.
So that
Okay.
0.6 of like I'm just getting it like the same work will do the like what does the round function will do? Is that will do the same function, or else it'll round up the values, like if the decimal value is like 0.76, it'll round up to 0.8 or what?
Okay. Now let's use it.
Actually, round function will round till first decimal after a point.
Just a minute. Okay, we'll print both. Okay. Can you see the difference here?
Yes,
So,
first.
so it round up to the nearest integer, and the nearest integer is 0 here. Are you getting that, right? Okay. Okay. So guys, let's move forward. Let's try to understand the big O notation here. So when I say big O notation, this is the notation to represent the time complexity. How the code is running, or what is the time complexity? So whenever you write a code or you go for any coding, problems or practice, you will see there would have been mentioned the time complexity in terms of big O notation. That means they are telling you write the code, but don't exceed this time limit. If they wrote big O notation small n, that means they are expecting a linear time complexity. If they mention O equal to O n square, that means they are mentioning a what? Non-linear time complexity. So based on the requirement, you have to write the code. Now, when I say linear, non-linear, that we'll try to understand here. If you see time complexity of linear search that we just now wrote, this piece of code, this function, right? This piece of linear search function, the time, how to write the time complexity of this linear search? This algorithm has a time complexity of order of n. Because the running time is directly
Your
proportional.
voice is breaking, sir. We can't able to hear properly.
My voice is breaking, is it? Hello?
It's clear, maybe
It's clear. Maybe
Yeah, that happens.
yeah, on
Either
the
my network or your network. Two possible ways, guys. But I like my network is always fluctuating, to be honest with you, because here lots of time hailstorm, cyclones. Okay. So yeah, maybe in this case your network was clear to others.
Okay. Thank you, sir.
Yeah, Divya. So now you are, am I audible to you?
Sir,
Is it
yes,
clear?
now audible. Now audible.
Okay.
Okay.
Okay. Now, can you see why I told order of n means what? Like this is the directly proportional to the size of input array. So when I use 10 elements, I got lesser time. When I used 1000 elements, I got a like more time than the previous one. If I use 10,000 elements, again more time will be taking. So this is a linear relationship. When you increase number of size, the time is increasing. When you decrease number of size, the time is decreasing. So that's why this complexity is order of n. That means depends on the size of the list or array. Okay. Now, this is easy, guys. Like this notation things you are going to encounter every time we are going for coding. This is not a problem to understand. And okay, now this is linear search. Okay, if you recollect, what are the algorithms we are going to discuss? Linear search and binary search and Euclidean algorithm. So one search we discussed with coding. Now let's try to see what is a binary search algorithm. Now, what is the difference between a linear search algorithm and a binary search algorithm? Now, this is actually a very efficient way, and it is going to take less time than linear search. Same thing we are going to do, but in a different way. Now, here the point is to show you these things is related to our algorithmic thinking, guys. So one person thought to find the element in the array by using linear search. One person tried to think to search the element by using binary search. Now, whose algorithm is efficient here? Now, first of all, before that, let's try to understand what is binary search. So first of all, in binary search, you have to do one thing. First thing, you have to sort the list, or you have to sort the array that you are going to pass. The objective is same. You have been given one target, you have been given one array, you have to find that target from the array or the list. Now, the first condition for binary search, you have to sort the list from increasing to decreasing order. Now, why we are doing this? That is having some, understanding here. So it works. So first of all, binary search is an efficient algorithm to find the position of the target in the sorted list of values. That's why I made it bold, so that you will understand. You can't run the binary search in a random thing in array. You have to sort that list or array first. Okay, and it works by repeatedly dividing the list into half. We'll see the algorithm one by one. Okay, so first what it is going to do, it will divide the list into half, and it will search in the first half and then search in the second half. We'll see how this is working. That means it is not, the point is here, it is not going one by one. It is dividing the list into half, then it is searching for the required element. Okay, now how this is taking and searching this, we'll see just now. But here the time complexity of this algorithm is order of log n. Okay, now what is order of log n? We'll also see with examples. I'll show you what is order of log n. Those who are totally new to this terminologies may be getting confused of what is this n and log n. So n means directly proportional, right? The number. So here n means the size of the array, isn't it? When I say log n, that means I am this size of array going to be passed inside logarithmic function. Now, how this is logarithmic function? After understanding the algorithm, you are going to get. Now, this piece of diagram, I am also going to use my pen here. So if you see here, what is the example? This is my array 1, 3, 4, 7, 9, 11, 13, right? 13, how many blocks are there? 7. Are you getting it? There are 7 blocks. So what is the length of my array here? 7. That means 7 indexes, but in different index you are storing different values. That is a different thing. But I have 7 blocks where in each blocks we are storing some values 1, 3, 4, 7. Now what is our job here? Our job is to find the number equal to 4, the index number of the value equal to 4. Now if we will use linear search, what you need to do, you have to go this, then this, then this. If you found this, then return the value like this, right? But in binary search, the algorithm is a bit different. What it will tell? It will tell you first find the middle index of the array or list. Now, how to find the middle index?
Total by 2.
Yeah, total by 2. But in case if you have here, if you have odd number of total length, that is 7, that's why it is easy for you to tell this position is the middle, because 3 side here, 3 side here. What will happen if I have even? So to handle that, what we'll do, we'll first consider the first index, consider the last index. So what is the first index? First index is 0. Last index is, what should be my last index in this example?
6.
Correct, 6. Now to find the mid index, what you need to do, you have to do 0 plus 6 and this by 2. When I say this, can you recollect what I'm doing?
Division.
Right, that means the quotient value,
Quotient.
right? If you do this divided by 2 and if you do this means whatever may be the remainder, or is it totally divisible or not, take the quotient values. So if I say 0 plus 6, then this by 2, then what is the value I am going to get? 3.
3.
So what is the position here? This is 0, this is 1, this is 2, this is 3. So now this block is my midpoint. So first, again, I'll summarize. First, we have to sort the array in increasing order. Then we have to find the midpoint. This is the second step. Now, see guys, here I am mentioning the steps as well, because this is how algorithms works. You have to decide the steps part, then you write your code. So first step, I ordered it. Second step, I found the midpoint using this formula. Just now I told. Now, once I find the midpoint, I will check what is the value associated with it. 7, right? Now, what is our target? 4. Here we'll see whether 7 greater than equal to 4 or not. If 7 is greater than 4, what does that mean? That means 4 is situated left hand side to 7. Please think. When I say 7 greater than 4, if it is true, that means 4 is situated this side. And this is the reason why we sorted the array in increasing order, so that every number that we can get, we'll see whether it is present to the right or left. Now, as our target variable is 4 and our mid variable contains number 7, so 7 is greater than 4, that means this is true. 7 is greater than, so first of all, it will check whether 7 is equal to 4 or not, which is not, right? No. Then it will check whether 7 is greater than 4 or not. If 7 is greater than 4, then go towards left. If 7 is less than 4 or any number is less than 4, then go towards right. Making sense here, right? Okay, so once you decide 7 greater than 4 and you went towards the left side, again you have to repeat the procedure. What is the procedure? Again, from the left hand part, now this is your array. Now this became your array because you didn't find 4 in this block. In this block, you didn't find 4. Do you agree? And you can see here, we are eliminating the time by going each element here. So this piece of 4 piece of block we didn't reach, and we conclude that in the first 3 block, 4 number will be there. Now, once we decide this is our new array, okay, again, what is the step to find the midpoint? How to find the midpoint? What is the starting index? 0. What is the ending index?
0. 0 plus 2.
1, 2, correct. 0 plus 2 divided by 2. So what is the value? 1.
1.
That means this is 0, this is 1. So this block is now our what? Midpoint.
Yes.
Now this is midpoint. So once you find the midpoint, you have to check for the value, whether
Yes.
this is equal to 4 or not.
No.
So whether 3 greater than 4?
No.
No. That means if 3 doesn't 3 is not greater than 4, then 4 will be situated right side hand to the
The
three.
array, yes.
Yeah, 3. So now that's why if it is no, then go towards the right of the mid value. And as soon as you go towards the right of the mid value, the value equal to 4 now. So 4 equal to 4, it is true. Now you
Yes.
find it.
It means this search can be done with only ascending order. Now, if it is shuffle, we can
Yeah, so if it is
sort it and
shuffle, correct, right, exactly. So that's why the first step is to sort it, because if you don't sort, you won't be initialize this condition, whether that is if it is greater than, whether it is left or it is right. That's why we need to sort it first.
So sorting can be ascending or descending, anything.
No, see, that depends. So suppose I sorted in ascending order, that means if 7 is greater than 4, where I am looking? I am looking at the left hand side. If I'll do it in the descending order, then where
The
I'll
condition will depend.
condition will depend. So according to your sorting, you have to decide whether you have to go to left or to right.
Okay, sir.
So as we made it in a ascending condition, that means the smaller numbers will be towards left and the larger numbers will be towards right.
Yes, sir.
Okay. Now this is the algorithm. Okay. Now let's try to implement this with code. That is important here. Let's try to. Why my pen is not going? Okay. Yes. Now let's do the same thing. Same thing using the time function. Here have I used? I'm not using time date function. Here I used not this model. This is another model. So let's try to understand the code here. Okay. First of all, I decided to give the name of my function as binary search. And the input parameter is list and the target. The list I'm going to pass, the target I'm going to pass. Here, if you recollect my explanation, okay, I think I have to draw it again. How many are there? There's 7, right? 2, 3, 4, 5, 6, 4, 5, 6, 7. 7 was there, right? So now if you see this space where we are mentioning the start index and the last index in this function. So start index will be 0, last index will be the length of this whole array minus 1. That's why this is 6. How we are writing, how we are implementing same that we just now discussed in the code. Okay, let's try to understand. So start index I am doing initializing at the start position, end position is my length minus 1. Now I am using a flag here. If you recollect our initial session, I used this term flag, right? So flag here to false. So why I am using this flag function? Why I am using this flag function?
If the target is found,
The mid value, maybe for the mid value.
Right. So to find the function or to find the value, I am using a flag here. That means here I am holding the red flag. That means number not found. So as soon as this flag will change to true, then I will change the flag color to green. And I will tell like, okay, I found the number. Okay, that is the reason why I initiated and indicate this with a flag where found equal to false. And we'll see when this found will change here. So below here, we are going to change this condition to true if we found the number. Now, again, I used a while loop. Now, can you tell me why I'm using a while loop? Because I want to run it, right? I want to run this as a loop until I found my target value. Right now, what is the condition to find my target value? So I am telling the system, run this while loop till when? Till start is less than equal to end. So when run this loop when start is less than equal to the end value. So suppose here, so for this exact question, what is the start value here? So I'm telling while 0 is less than equal to 6, then run this loop. And this condition always satisfy until we reach our desired output. This condition will always there. So until this condition satisfy, this loop will run. Now observe carefully here, and not found. That means the flag is still false.
But Ashish, like the for will also do the same thing, right? Why we are doing like using while here?
Yeah, but the for the for loop here, I will tell you why we are using a while loop, because every time this start and end position is going to change. If you remember,
Okay.
once we found the mid number, then we go to the left hand side, and there we consider this as our array,
Yeah.
and there the start and end point will change. Now using the for loop, you can't do this because it will run through the whole loop.
Okay, so it will only the for loop will only run through the specified range. It can't be able to change the range in between.
Correct. And in between, if you want to increment or decrease or do some values, we can't do that. But using a while loop, we can change this value in between. Okay, let's try to understand what is happening. So run this loop when the flag is false. Okay, and define the mid index number there. What is the mid index number? We already saw this. Start plus end. What do we call this, guys? A double slash.
Floor 2. Floor value.
It returns quotient. This is a reminder. This is reminder.
Modulus will give the remainder. Floor division will give the quotient value.
Ashish, I don't think we can hear you.
Yes, we are not hearing you.
Not audible.
Yeah, you're on
Ashish, you
mute, I
there?
think.
Yes, you are on mute.
No, we can't. He was asking like you guys can able to hear me.
Can you hear me now?
Yeah, we
Yes,
do.
sir.
We do.
See, that's why I joined from two systems, one from phone, one from laptop. So that's why some issue. Okay. So can you? I was asking, what is this called? Can you recollect? What is this sign?
Floor function gives quotient. This one is modulus give the remainder.
So this is called floor division or something like that, right?
Yeah, floor division.
Floor division, right? Okay. So using floor division, what we are going to do? We are going to get the mid index. Okay. Start index we got, end index we got. Now we got the mid index. Now, if you see the algorithm that we discussed, if mid equal to our target or not. If you recollect here, it was like 7 was there, right? And here we are checking whether 7, our target was 4, right? Whether 7 equal to 4 or not. So this condition is for that, whether the target is same as the mid value of the list. And if this is true, then change the flag found to true. Because in that case, you got it, right? If it is 4 here, then 4 equal to 4, that you found that, right? And you change immediately, you found the mid value equal to your target, then you change the flag to true. Now, if this condition doesn't satisfy, then what happened? You will check whether, now here in this case, it was 4, the target and the mid value was 7. Whether 7 greater than 4, here same thing I have written here. Can you try to understand? Target is less than the mid value. So here target is what? 4. Less than the mid value. What is 7 in our example, the above example, right? 7. So do you agree with me? This is the same thing we are writing. If target less than the mid value, 4 less than 7.
Yes.
Now, if 4 less than 7, then that means 4 is coming into what? Left hand side or right hand side? Left hand side.
Yes, left hand side.
Right? So
Left.
once left hand side is decided, what is the start position now? 0. What is the end position now? Just before the mid one. So here, if you see here, initially the end is the list -1, this position. Now, as soon as you found the number will be fall in the left hand side of the array, here your end position will change. Start position will be 0. Now, what is your end position? Length of this -1, or you can say just before to the mid position. That's why if you see here, if you found our target is less than the mid value, then change the end position or end index number to the mid index number -1. Now what my start index will be 0. Now my end index will be mid -1. That means it was 4, right? Now it will be 3. Now, once we do this, again run the loop, again perform the same. Here, that's what I was trying to explain. That's why we're using a while loop, because we have to change this index position frequently based on the condition. But using a for loop, you won't be able to do it because it will run through the whole loop. And similarly, if so, this less than this, in the else part, what I am considering, if 7 is less than 4, then what you need to go? Right hand side. Now, if you go to the right hand side, what position of the index number will be changed? Starting position. Now,
+1.
yeah, so you have to find in this part, left hand side, sorry, right hand side part. Now here, what is the start position? Mid +1. So if it is left hand side, then the end position is changing. If it is right hand side, then the first position is changing. So initially our start position is, see guys, initially our start position is 0 and the length of list -1, right? If we, after checking the condition, if we found it is in the left hand side, then what we are going to change from here? Not the start, the end. Start will be same. If it is in the left half of the side, the start will be same. Only the end from here to here it will come. Then we'll repeat the same. Now, suppose if it is not in the case, the number falls in the right side region, then from this to what we need to change? The start, because the end will be same. Are you getting what I'm saying here? It will take some time. Please rethink it, okay? And I will suggest after the session also, because these sessions are designed to exercise our brain on coding, guys. The more thinking we'll do on this, the more your brain will be flexible to the coding and the understanding. And I am not expecting all of you to get it in 100%. Just only few percentage of, if you are getting, that is also sufficient, guys, as per me, because this is how I learned. And to be honest with you guys, I'll tell you one thing. While learning while loop, I was like so confused initially. I took almost 7 days to understand a particular complex while loop. And every time I write the code, it is leading me to infinite loop running situation. And this is, I hope this is also happening with you guys also. That happens.
And Ashish, can I add something here?
Yeah.
So Ashish, yesterday I saw like in Kaggle, there is a program in 4 hours they are teaching Python, like what we have learned in the past week. They are teaching in 4 hours, everything.
Okay.
I
So,
got
yeah.
like my mind blown. Like, what is this 4 hours they are teaching? 1 week concept.
No, see, that is a business strategy. Nowadays, people are running like whenever they see a new thing, they think of like, okay, let's make it a business. But it's not like that. Learning is a different thing. Business is a different thing.
Like you were saying, for 4 hours, I think yesterday in YouTube they were saying beginner to pro in 3 hours. I'm looking like, am I a joke to you? Like I've been in this for 7 to 8 days, and I'm literally, going mad because of this programming. But within 3 hours, you'll make me pro. How it could be?
Yeah, but that is actually that is not the case. What we need to do, we need to be consistent in this situation. That's all. Like we need to learn the coding every day. Like now these days, because of the workload, I'm not doing. But past 1 year, every day try to spend some time on coding, because I think this is increasing your brain's thinking capacity. If you see here, a lot of things we are thinking here. Go to the left, this condition, go to the right. So this is a brain exercise we are doing. Even if we are not getting in 100%, but it is beneficial for us.
So Ashish, what is the mindset we need to have to develop that kind of thinking?
Definitely, like first of all, you need not to burden yourself that I'm not getting. Like you have to be happy that you are, at least you got something, and you are understanding. And those who are not starting from the scratch, for them, I think it will be a very good feelings that you are learning this with a while loop, for loop. These are the computer science students need to, do.
I am from commerce background.
Yeah, so you will be very happy that from commerce background, and you can write a simple code. Now you can tell I can write a code to search a number from the list, and that also within this time interval, or by taking this time. This is a great achievement. So you need to be happy while learning small things. And I know you won't be able to get it 100% at right now, but eventually if you'll progress. After 1 month, if we'll look back to this time and see this example, you'll think like, okay, now this is easy for me. This is very easy, that I can understand now, because that time you already explored complex coding after 1 month. But the thing is, till 1 month you have to spend the code kata you have, right? The code kata, try to do at least 1 or 2 problems daily, so that exposure to coding will be there. Okay, now let's back to our explanation, guys. We just got sidetracked. And today also, guys, I want your help. I want to leave at 11 exactly. I have one medical appointment. So at 11 we'll stop today. Exactly.
Sure,
Okay.
Ashish,
Yeah. So here, if you see, so using the while loop, guys, here left hand side and right hand side, when we decide where our target is falling, whether in the left hand side or whether in the right hand side, 2 things we are doing. If it is falling in the left hand side, from this 2 parameter or this 2 variable, I am changing the end, because left hand side means the starting will be same 0, and end will be from length -1 to this position. But if the number is falling in the right hand side, then the end is now changed from 0 to this position. From 0 to this. Yeah.
Like if you can run it with some variable, like it will be more easy to explain.
If you give more,
Right. If you are giving some values to it, it will give the result, right? So we can control, like you can see it how it happens. Like for this function, can you give some value?
Okay. The
Creating a
value
list
to check.
Yeah.
We'll do that. Once I'll make you understand this code with example. Again, we'll calculate the time also, guys, and we'll compare this with the binary, the linear search. Okay, we'll do that. We'll do that. Just let me explain what we did here. So can you understand the code here? What we're doing?
So like one question, I didn't get this and not found. So if it is not found means it is true right here. Found is
Okay.
false. If it is not found is true. Right?
Okay. Okay. So now if you see, if this is found, okay, you are correct, or Ramai did it wrong, and not found. So here found is false, not found means true, right?
Yes, sir. It should be found, right?
Huh. Right. If, oh, just a minute, I'm now getting confused. Okay.
We written if found in the bottom.
Right. So if found in the bottom, we have wrote. I think we need not to have this condition, right, guys? We need this condition, right? No. So when start equal to this, and even if the flag we are changing here somewhere, then it will. Okay. So I mean to say what we are doing here. We can remove this not found, guys. This is not required. So because we are handling this here if found. So while this condition satisfy, go to the mid index, check this condition. If you found the target, make the found flag to true. Okay. And if you don't found this condition, then go for this condition, change the mid value and start value and end value. And once you run this code again, like in the loop, then one point of time it will be there where you will find the mid value will be exactly equal to your target by doing this. So here we just took only small example, consider a large array, and we'll try to repeatedly do this. So one point of time, this condition will true for you. Once this condition will true, then the flag will be automatically changed from false to true. Now, if this is true, then return the mid. Now, what is the mid?
Index value.
Correct. I was expecting the answer index value. It is not the number or the value inside the array. It is the index number. Okay. So that means we found the index number of that number in that array for that position. Now let's run it. And if you
And Ashish, sorry to cut you off. Like, we have used if and elif and then else, right? So, I think on the other day also I've asked you like why we were using elif. So, like we can use if else and then also if whatever, right? Like why we were using that else kind of thing.
like this, you are saying?
Yeah, like we can use another if in the bottom, right? Like start equal to mid. Like, what is the actual use over there? Because whenever I'm using the elif on my own, like when I am doing also, I'm getting confused. Like yesterday also I did the same thing, and but I'm
So
not.
see, the simple logic you need to keep in your mind. If you have multiple conditions to check, either
Okay.
check this or so, like think like in a statement that you are either in your native language or English language. Either I need to do this or do this or do this or do this. So this either is if, or the number of or that you are going to use elif.
Okay, so whenever we were in a position to use the nested walla stuffs, then we will use this elif statements.
Correct. So conditions, the more number of conditions, the more number of if and elif will get. And if you like complete all your condition, then else statement will come. If doesn't satisfy, then what you need to do?
Okay, so in a nested situations, we'll use elif until and unless if it is not required, we can go with the if and else.
Correct.
Get it.
So Ashish, if we use all ifs, the program will get confused and it won't give us any output. Am I wrong?
Like this, right? If like this one, right?
Yeah.
So if you'll do this, again it will run, but I don't think this is a good practice to use if and if. So the syntax is if elif, then else. And now the elif means the additional conditions you want to check. Now, if you see here, you can run the code using if, but this is not the good practice to, use if and elif. Like this is the first condition. If means the first condition. Always if means the first condition. The second condition will be inside the elif condition. Third condition again in the elif condition. But if you used if multiple times, that means this is the first condition. The system will think this is the first condition. Are you getting what I'm saying here? So if we'll do like this means this is the first condition. Again, system will come to this line. Again, it will think this is the first condition.
Okay, I got you. Okay.
Yeah, if you have multiple conditions, then first condition, second condition will be written in elif. So now the system will understand these all are part of one thing, like multiple conditions, but one thing. Okay. Now, if you see, it is returning me the index number of the mid value. If you don't found the number, again return -1. I think this is clear. Now this code is clear. Now let's try to compare this with our what? With our linear search algorithm. Okay, guys. So how to compare this? I think this is something I need not to write. Okay. Again, same thing, guys. Same thing. Numbers in an array of 10. Target is our 10. Time I am calculating using timeit function. And here, what is the changes I am doing? Instead of linear search, I am using this function this function that we defined, right? This function. Now, this function, the input value is this array, and the target we are passing as 10. And number of times we are going to run as 1. Now let's see what is the result. So guys, I think we did something wrong here. We have to keep this.
I think you'll have to add the not found to this.
And what is that? Not found, right? If we don't use this, okay, it is looping infinitely, and this is also why this is happening. I'll tell you, okay, why this is happening. First of all, let me run and show this code to you. Now it is ran. So this is why you need to be very conceptually clear on these topics, or else it will be, still something wrong. What is wrong here? Numbers, guys, try to find out what is wrong here. I ran it. I didn't stop it. Stopped it, then ran it. Okay. I was scared. Okay. Now, if you see here, what is the result? And I'll tell you what is the use of not found here. What is happening, guys? Once consider the last step of the loop. Consider it. Okay. Consider you removed not found. Why it is not found? That means you are saying this is false, and if I will make not found, that means it is true, right? Okay. So this means run the loop until what? Until start less than equal to end and not found. If you consider the last step of the loop, what is happening at the very last step where you found the value or you found the index number, what is happening? This is going to change to true, isn't it? At the last step of the loop, when you found the value, this value changed to true, right? Yes. And to stop the loop, we mentioned and not found. So this not found is not resembles to this found equal to false. This is to capture when this found equal to true. So run this loop till found equal to false. This is what it means. That's why when we removed this, it ran, infinitely, because we didn't give the condition when to stop the loop. Because start less than equal to end will be there. So can you tell me what is the last step? What is the start value and what is the end value at the very last step? When you found the number.
Mid plus 1 is the start value, n number will be the last value.
Last value. So in our case, what is that? Start will be 0 and end will be 3, right? 3, right? So 0 less than equal to 3. So that condition will satisfy every time. 0 equal to less than 3, although you found the number. So as soon as that condition satisfy, and if you don't write this line, then this while loop will keep running. So to stop the while loop, you have to satisfy this, and when the value is what? True. So this means when the found value will be true, then stop it.
Okay, so for that we were using the not operator to change it. Like if it is true,
Correct.
then you can stop it over there.
Correct.
It's,
correct. So
it's confused, sir. Can you come again?
yes, again. So that's why. So, okay, first of all, found flag will be false initially, right? This one you understood, right? Here, if you see this piece of line, while start less than equal to end and not found, that means run the while loop till this condition satisfied. Else stop it. If you don't find this condition satisfied, then stop the while loop. This is understandable, right? Now let's try to understand why we have given this condition. The loop will run for this start less than equal to end. That is for sure. Every time the loop will run, that this condition is going to satisfy. And not found. That means what we are saying, not found means when this is true. When this is true and satisfy this condition, again I am repeating, when this is true, the found flag is true and satisfied start less than equal to this condition, till that time you run. So when you found the flag will be true, then stop the loop. That's what it is telling you.
Actually, and found means it is false, so that we are giving not found, right? We are assigning the found equal to false, so that we are giving here not found.
Correct. But here, this is something for your brain actually. This is a brain exercise. You have to understand it. Why? Because by looking here, you can say not found means we are talking about what? True. And that is actually the concept here. When it will be true, then stop the loop. That's what we are telling here.
Okay, now got it, sir.
So that means in between here, when you found the flag, when you found the number, you are changing the found flag to true. So as soon as you see this is true, then stop executing this loop. That's what we are telling here, to while loop. So that's why while loop, to be honest with you, I took at least 2 to 3 weeks to understand while loop. And it's and all of the time I tried, and please try to implement while loop, guys, because this is very useful. And some of the times you'll see your loop will running like forever. Okay, so here, as soon as you found the flag equal to true, then you stop this while loop. That's why if I remove this, it is running forever. Okay, and if you see, can you see what is the time taken? Is it like quicker than binary, or how is it? Can you compare? This is the time taken, 0.50.
Same, I think. It was also taken 4 seconds. When we ran the second time, it taken 3 seconds.
So here we are searching for this, right? Okay, let's compare this now. What is the target? 10, right? What is the value it is showing? 0.503.
Yeah.
Here, what is the value? 0.504. Can you tell me now, like guys, like I'm talking like this is quicker than linear search, but we are getting different values here. Why it is so? But it is not like more than the binary, it is kind of equal to it, like just a fraction of second, not fraction. It's like 50 means 1 second divided by 1 lakh, right? 5 zeros in one. That is the fraction of second we're talking here. So kind of thing, it is not more and less, kind of similar. Now my question is why this is similar? Both the algorithms, this should be quicker, right? Here we are not iterating each number, but we are doing it in a loop. Like by dividing this to half, then looking into the thing. Why it is similar? The answer to this is because the length of the list is pretty much small. Okay. Now let's do one thing. Let's go for 10,000 numbers. Okay. 10,000 numbers, and the target, let's take the last number. What is the target here? 9,900, right? So let's now compare like this. Okay. Now 10,000 elements in our list, and what is the time taken? Just a minute. 0.000614, right? Now let's do the same thing here. What we need to do here, guys? Number equal to
list of range,
list range 10,000, right? And the target would be 9,999, right? Now let's run this and see what is happening. Can you see the difference here now?
yes,
Same thing. It was taking, what is the value? 0.0006 second, right? Here 0.509. Can you see the same task for 1,000, 10,000 elements? How quicker this binary search is? Same thing we did. So this is, so I like to take the session based on this experiments. I always try to show, okay, this is a theory and this is a practical thing, and yeah, this is working.
Bubble sort algorithms.
Yeah, bubble sort also one type of quicker sort algorithm that also you can try. Okay, that means you can try this with bubble sort. You try to study what is a bubble sort, see the algorithm, write the code like this, and do your experiment. Good exercise, very good exercise. But here also I have one exercise for you guys. Before that, I will tell you about what is the time complexity order n and order log n base 2. So if you see here, a logarithmic curve will look like this, and a linear curve will look like this, straight line. So if you see logarithmic curve, logarithmic function, to be more precise with the image and the graphs, you see here. What happened? Anything. If you see here, this is the figure. This is how logarithmic function looks like. That means with the input, how the output is varying. Okay, that means in the x-axis the input. Here the x-axis means the number of elements inside our array. That is the x-axis. Y-axis means the time we are consuming. So what we are getting here, with the increased number of elements, the time will increase, but not in a linear way, but in a logarithmic. That means in a slower way. If you see here, this is linear and this is logarithmic. The more the number of elements, the quicker it will be from linear search. This is the what you can say graphical representation of order n and log n. And now can you please try to do this for me, this small. So this is Euclidean algorithm, guys. So instead of I explain you the Euclidean algorithm, what I'll do, I'll explain you the concept. What is the Euclidean algorithm? Now you have to write the code for me. Now what is the Euclidean algorithm? Euclidean algorithm is a method for finding the greatest common divisor of two numbers. When I say greatest common divisor means which can be divisible to both but the greatest one. The GCD is the largest integer that divides both numbers evenly without leaving a remainder. Now, how this algorithm works, I'll explain the algorithm to you. Now you need to write the code for me. So first, what is that? Take two integers. Here, one thing I missed, take A as the larger element and B as the smaller element. You can keep that in mind, okay? Or else, with the input, you can define which one is the larger. But for simplicity, let's make A is larger and B is the smaller one. Okay, so two integers A and B. If B is equal to 0, the GCD is A. If I give two numbers 5 and 0, so what is the GCD? 5. Because the smaller number is 0. If B is not equal to 0, compute the remainder by dividing A by B. Okay, compute the remainder by dividing A by B, and the remainder you can store in a variable called R. Now in the next step, what you need to do, you have to replace the value. Now A will be becoming your B. That means whatever the value present inside B, that will be now coming to A. And whatever the remainder you get in R, that will be your B. And you have to repeat this step till you find the smaller number will be 0. For example, I'll make this task easy for you. Suppose 60 and 40. What is the first step? Bigger number is A, 60, smaller number is B, that is 48. Now 48 is not equal to 0. So we compute the remainder. Remainder by what? 60 by 48. So when we say 60 modulo 48, what is the remainder? 12. Now you change this A value from 60 to this 48. Now A becomes B and B becomes R. Okay, that means A equal to 48 now and B equal to 12 now. Now 12 is not equal to 0. Again, you have to do the same. What you need to do? 48 divided by 12, then get the remainder. Here remainder will be 0. Now A will be B and B will be remainder. A will be 12, B will be 0. Now once this one of the smallest number is now 0, you can say 12 is the greatest common divisor of 60 and 48. Are you getting it? Can you try to read it for 1 minute and can you try to write the code?
Sir, actually, here is a library function called in maths GCD is there, so we can do it by directly by that system.
No, that is fine. That is so for in Python, for everything you have a module. So that doesn't mean that. So this is for your brain practice exercise, right?
Oh.
Okay, do one thing, because I told you like I have one appointment at 11:15. So take this question, because this is the last topic for the session. Take this question, but make sure you will tell me the code tomorrow. Is that fine?
Yeah.
Yeah, Ashish.
And if you're not able to do also, I'll do. No worries. Just try to do it, but don't use any library, guys, because here we are exercising our brain. You write the code yourself. Think about it. It will be very easy. Just 2 to 3 lines of code and you are done.
Yeah.
Okay.
Yeah.
Any questions for today's session? And I think we have one. So these things we left out today, which we will cover tomorrow. Don't worry. Why this is not coming? Yes. The data structure. So again, guys, I don't want to make you like this is dark. This is the definition of heap. This is the definition of binary tree. I just want you to tell you the definition, also the code implementation of this. And it will be a bit complex for you guys, this data structure and code implementation, because this is a critical, like if you're going for SD role, like software development role, this kind of things they will ask in the interview. How you can write a code for stack, heap, binary trees. These are like a bit advanced concept, but I want to give you that context so that your brain exercise will be there to understand the code.
Sure.
Okay, tomorrow I'll show you this with coding examples and we'll see. And then these things will complete. Okay. Any questions or anything? I have uploaded the the files also in the G drive for today's part. You can refer the notes also. And please make sure you have to answer this coding question tomorrow. Okay, this is the Euclidean algorithm. This is called Euclidean algorithm. So with this, can we wind up the session, guys? That is okay.
Yeah, Ashish.
Okay, guys. So see you tomorrow then, guys. Bye. Have a good day.
Yeah, have a good day, guys.
Yeah.
Thank you, Ashish. Have a good day.
Bye.